Relationship between traffic speed and density is described using a negatively sloped straight line. If Vf is the free flow speed, then the speed at which the maximum flow occurs is, for options given, 0, Vf by 4, Vf by 2, Vf. Okay, it's a question from 2021 gate paper, civil engineering, from set 2. Okay, here to solve this question, we need to know few things here. One is speed, traffic speed. Another one is density. Another one is Vf is the free flow speed. Also flow. We need to know these terms first. Okay, let us define what is speed. Okay, speed, it's distance covered by a vehicle within particular time. It's generally denoted by V. Units are meter per second or kilometer per or whatever, because it's distance by time basically. Now uh, another one is density. Density is in for materials. What do we say? We say that uh, weight of a material divided by volume. That means the weight of a material within a particular volume is called as density, kilonewton per meter cube. Or if it is density, that is unit weight. If it is density, it's kg per meter cube. Okay, units are like kg per meter cube. But these are vehicles, and these we are talking about vehicles on a road. So how does density is defined? How is that density defined in this case? As number of vehicles divided by distance. So how many number of vehicles are there within a particular distance? It's like how much weight is there within a particular volume. In the same way, for a material, how many number of vehicles are occupied within a distance is density. Okay, that is density of the uh, flow. So anything in the transportation engineering. Now, now another thing is flow. Flow is defined as, it is denoted by Q. Generally, density is defined by K. Okay, density is defined by K. Flow is defined by denoted by Q. It's something, number of vehicles. Okay, number of vehicles. This is a road. Let us say number of vehicles which cross a particular point on the road. Number of vehicles which are passing this particular point within a particular time. Suppose I will give you a time of 1 hour. In 1 hour, how many number of vehicles are passing this point? So basically units are number of vehicles divided by time. Okay. So how many number of vehicles are passing through this point in some time? Okay. Now how Q is related to V and K, V and density. Let us discuss that too. Okay. How Q is flow, units are number of vehicles in particular time. And how K is defined? K is density. Okay, it is number of vehicles divided by length, in particular length. And how V is defined? V is speed. V is speed. So distance or length covered by a vehicle within a time. So if you see these three units, number of vehicles per unit time, number of vehicles per unit length, and that length should be covered by in particular time. So if you observe, Q is nothing but K multiplied by V, density multiplied by speed. See, density is number of vehicles in a particular length. That length should be covered by covered within a time. So that means automatically those many number of vehicles are covering that much length in that particular time. Okay, so those many number of vehicles are passing, are covering that length, are passing that end of the length in that particular time. So that's how q is um, can be defined is defined as k multiplied by v. Now we came to know all these three. Now how k and v are related? How k and v are related? So that's given in the question. If you read, this is V, this is K. They are related using a negatively sloped straight line. Okay, negatively sloped straight line. Negatively sloped straight line. Okay. Now I'll just draw a diagram. Okay. Let us say this is speed. Okay. This is density. Now there is a road. Okay. Now if there are two sections, I'll say this is the length, this is the length. Okay, length between two particular points. Within that length, how many number of vehicles are there? Okay, that is called density. Okay, when the density is very high, okay, vehicles may not be able to move. Okay, right? Sometimes it may be zero, the speed of the vehicle may be zero. So ideally, if I have to say, when the density is very much, when density is very more, the maximum, when the density is maximum, speed of the vehicle may be ideally zero. Let us take this point. Okay, speed of the vehicle is zero, density is maximum. So that density where it is maximum, that is called jam density. Okay, traffic jam. When does it happen? When the vehicles are number of vehicles are more in a particular length. That's why the density is called jam density, kj. Okay, when kj is there, speed of the vehicle cannot be something, it can be zero also ideally, so it's zero. Now now in I'll take uh, let me erase this. Okay, okay, let me erase this. Again, I'll take another length. Okay. Now, speed of the vehicle. When can be the speed high? Suppose speed is very, very, very high. When can it be? When you don't see any vehicle in front of you, then only your speed will be very high, right? That means the space between the vehicles are very much high. That is the reason why you are going with that much speed. So when the spacing is very, very, very high, so that means the density, suppose this is the length, the spacing between the vehicle is very high, so you may not see any vehicle in a length. If you consider a particular length on the road, okay, you may not see any vehicle. So ideally it can be zero, density can be zero. Okay, or very, very less. So density is very less when the speed is very high. Okay, the speed with which you can go, that is free flow. Free when the flow is very free, there is no flow actually. Free flow. When there is no flow, that means free flow. When there is free flow, speed is very high. So that is the reason why the speed at which free flow is where the density is very less. That speed is called free flow speed. Now these two should be related by a negatively sloped straight line, which is given in the question itself. Okay, which is given in the question itself. Okay, they are related by negatively sloped straight line. Okay, see this. Whenever but ideally it cannot be, density cannot be zero. Ideally speed cannot be zero. Density cannot be that much high. So they are asymptotic to the axis. Okay, but it is linearly. So now we understood what is the relation between speed and k. It's negatively given that we know 2 points, but how to join them is we know. This is given data. Given data. Okay. this is Vf, this is Kj, jam density. Now, how Q and Kv are related, that we learned just now. Q equal to K into V. See, you remember that here K is proportional to 1 by V. Okay, but they are dependent linearly dependent. Why linearly dependent? This is given data. Okay, so when two parameters are linearly dependent, when any parameter which is dependent on both two parameters which are internally linearly dependent, then Q and K and Q and V, these are parabolic functions. Okay, parabolic functions. That is what the mathematical expressions. Suppose when two parameters are linearly dependent, then if any parameter is dependent on these both together, okay, then that parameter will be linked to these parameter individually as parabolic functions. That is how the mathematics is. Now we know, finally we know these two are parabolic functions, q and k. Q and V are parabolic functions. Okay, but how are they connected? Let us see. Okay, let me make a clear figure. Okay, Q K, Q V. Okay, now as we have talked, okay, if you take a road, Q is something, number of vehicles per time. Okay, in a, see, when the density is zero, density is zero means no vehicles. If no vehicles are there, no vehicle will pass a particular section. So of course, if k is zero, q is zero. Okay. Now, when k is maximum, that means jam density. When it is jam density, there are so many vehicles. If there are so many vehicles, we know that we know that vehicles will not move, right? When kj, v is almost tentative to 0. Okay, vf is tentative to, sorry, v is tentative to 0. When the speed is tentative to 0, then only jam density happen. When v is tentative to 0, that means flow will not happen. Means flow means it cannot cross any particular point in a time. So q also will tentative to 0. That's how when k is kj, q is also 0. But there is a certain point, and what we know, q and k should be linked with parabolic function, and there are 2 points which are actually on the same line. Other point should be somewhere, okay, like this, and those should be connected with parabolic function which we know already, and that point uh, is generally focus we call for the parabolic, and that is the highest peak point where you can get q maximum. Okay, and that peak point is nothing but, it's a symmetric parabola, is symmetric. That's why peak point, if you draw vertical line, it will touch at kj by 2. In the same way, q and v are also uh, linked by parabolic function. Now we will see, when the speed is zero, that means when the speed is zero, it's kj, right? When kj, it is q is zero, q is zero, because when the speed is zero, it cannot cross any particular point. So again, when v is vf, free flows, sorry, when v is zero, q is zero, that we understood. But when v reaches vf, that means we already discussed this. When it is free flow speed, means speed can be very high. When can it be very high? When there is low density. When there is low density means, again, no vehicles. When there are no vehicles to cross a particular point, so q also tends to 0 again. So it's like when Vf is there, again it is Q0. Again, to make a parabolic function, you need to draw like this. Again, there is a peak point which refers Q maximum. If you take that point should be focus, and that point is it will divide the parabolic into two similar halves. That's why this point should be Vf by 2. Right now, this mathematical expressions will tell you Q maximum will occur at Kj by 2, Q maximum will occur at Vf by 2. Okay, now we understood Q max occurs at Kj by 2 and Vf by 2. So then Q max should be Vf by 2 multiplied by Kf by 2, Vf Kj, sorry, Kj by 4. Okay, you cannot write Q max as V max multiplied by K max, which are nothing but V max is Vf, Q max is Kj. This is wrong. This is wrong. This is wrong because when V is maximum, K cannot be maximum. When K is maximum, V will be 0. V cannot be maximum. So for Q max to be maximum, optimized values are these two. Okay, so this is the thing. But what is asked in the question? In the question, it is asked maximum flow occurs when V is the speed is Vf by 2. Maximum flow occurs. So answer is C. Thank you.